copier, huh? All right, so 5.3, they call this approximating with the tangent line. What this really is called local linearization. Okay, so we're using local linearization is the technique. And so the idea of this is that you're trying to estimate to the best of your ability, without using a calculator, the value of a specific function at a not so nice point using a very nice point that's very, very, very close by. Okay, so for example, when we have this circle, and you can see the equation of the circle right there, x squared plus y squared plus 2y equals 4. Okay, so the point 2, negative 2 lies on that circle. Okay, so what we're going to do is we're going to estimate by using calculus the actual value of the function at 2.1. Okay, so in order to do that, we're going to start by coming up with the equation of the tangent line. So how do I come up with the equation of the tangent line? You derive it. Okay, so remember the derivative is going to give us what, by the way? The slope. Okay, so we're going to find the slope at the point 2, negative 2. Okay, so I'm going to start with this equation and derive it. We're going to have to use an explicit differentiation here. Implicit. Okay, because we got two variables. So what's the derivative of x squared? 2x, good. And then plus the derivative of y squared. 2y times y derivative, good. And then the derivative of 2y. 2 times the y derivative, good. And then is equal to 0. Perfect. Okay, so then I'm just going to set this equal to the y derivative. So I would start by subtracting 2x. Okay, and then how can I isolate the y derivative piece? Pull it out like a greatest common factor. So I would have 2y plus 2. And what would my last step be? Divide by that. Okay, so you absolutely can. So you could simplify this by just dividing everything by 2. I'm not going to do it because I'm just going to go straight into plugging in the point. But if you feel like that's easier to simplify than plug in, then just go for it. Okay, so I'm going to plug in the point 2, negative 2 that came out really nice. So I'd have negative 2 times 2 over 2 times negative 2 plus 2. So we get negative 4 on the top over, what's that, negative 2? So a slope of 2. Okay, so remember that finding the first derivative at a certain point gives us the slope of the tangent line. Okay, so if we're going to write the equation of the tangent line, what does the equation of a tangent line look like? What kind of function is it? Okay, so y minus y1, it's a linear function, right? So you guys remember y minus y1 is equal to m times the quantity x minus x1. Okay, so this comes back into play. Okay, so again, I'm using my point of 2, negative 2. So what's my equation going to be? Y plus 2 is equal to my slope, which we just found to be 2, and x minus 2. Okay, so at this point, what I want to do is I just want to set it equal to y. And I will tell you for simplicity and making this as easy as possible, do not distribute the 2 through, leave it in that quantity form. So just subtract the 2 to the other side. Okay, so it kind of looks like that vertex form. Okay. All right, so now what I'm going to do is now I'm going to estimate the value of the y when the x coordinate is 2.1. So what am I going to do? Plug it in. Okay, so I'm going to do y of 2.1 into this equation, into the x, and do this without a calculator. See if we can do that. So start on the inside. What's 2.1 minus 2? It is exactly 0.1. And then what's 2 times 0.1? 0.2. And what's 0.2 minus 2? Negative 1.8. Okay, so that means that that point that would be 2.1 if we plug that into the original function would be really, really, really close to negative 1.8. Okay, if we wanted to see what the actual value is, we could plug it in and see. Anybody want to do that? You guys just trust me? Because we're estimating using the tangent line. So like the idea is if I was to scroll into this like really, 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 really tight, let's see how tight I can get into this. This point is 2, negative 2. So if I was estimating where 2.1 would be, that's like right there. So see how close the actual value of the circle is really, really close to the actual value of that line. They're super duper close. Does that kind of make sense? Okay, so they kind of ask us one more question on this for B. What am I going to do for B if they're asking us when the x-coordinate is 1.9? Into the linear one, right? So I would just do y is equal to 2 times the quantity 1.9 minus 2, and then a minus 2 again. So on the inside I have 1.9 times, or minus 2, what would that be? Negative 0.1. And then times 2 would be negative 0.2 minus 2, so that would be negative 2.2. Okay, so notice also that those two x values that we inputted were on both sides of 2. Okay, and notice that the two corresponding y values that we came out with were on both sides of the 2 value, which was negative 2. We got on both sides of it. Okay, so it's kind of the idea of limits in a sense. Okay, so here is another way to represent the exact same kind of question. We make this one a little bit, it looks more complicated, but in fact it is easier to deal with. If they give you an f of 2 is equal to 3, what are they giving to you? They're giving you the x and the y, right? So it's just simply a point, right? Normally we write points as like ordered pairs. Okay, just realize that's the same thing. What are they giving to you if they give you the first derivative of 2 is equal to negative 2? The slope. Very good. Okay, so this is telling you the slope, which when we did question number 1, we had to go through and derive it and then plug the x value in. So this one is a lot more simple. We're at the step now where we're just writing the linear equation. So what's my linear equation for this? Y minus 3 is equal to negative 2 times the quantity of x minus 2. Okay, so again, set it equal to y. I'm just going to add the 3 over. What's that? I don't know, but it's been in here for 2 days. It's driving me crazy. I don't know. Something in the ceiling. It's really annoying. I agree. All right, so my last step is just to plug 2.1 in. Okay, so notice you guys that the only way this works is if the value that you're trying to figure out is really close to an actual value on the function. So it has to be really close to the 2. Okay. So let's see, we got 2.01 minus 2 plus 3. So again, without a calculator, that's the whole point of this, figuring these values out without a calculator. What's 2.01 minus 2? 0.01, and then what's 0.01 times negative 2? Negative 0.02, and what's negative 0.02 plus 3? 2.98, right? Hopefully we can do that without a calculator. Okay, so that's it.
Wow.
Not too bad, right? Okay, so what I want you guys to do for your assignment is to do 1 through 5. Okay, so I'd like you to have 1 through 5 completed when you come to class on Tuesday. Okay?